The universe's first explorer might have been a thought. Before planets or even light existed, something journeyed between the very dimensions of reality. You are about to discover 30 incredible theories explaining who or what that first interdimensional traveler could have been. By the end, you will see the origin of everything in a completely new light. We will investigate if a random fluctuation of energy could have stumbled through a crack in space-time, and whether the cosmos itself might be conscious. What single idea about reality's beginnings feels the most true to you? The first theory rewrites the traveler's origin story entirely. It suggests the pioneer was not a thing but a thought. Before the first particle, before energy or time, a form of pure, universal consciousness may have existed in a state beyond our dimensions. Picture a mind with no brain, an awareness with no single point of origin, simply being. This primordial consciousness, driven by an innate need to understand itself, did not move through space. It did something far more profound. It stepped into the very concept of space as it was being born. When the Big Bang ignited the furnace of our cosmos, this consciousness peered into the chaotic, unformed reality from its higher dimensional state. Its act of observation itself could have been the key event that solidified everything. In quantum physics, a particle exists in a blur of possibilities until it is observed. What if our entire universe was that blur? The first interdimensional traveler, by merely looking, may have collapsed the infinite possibilities into the single, tangible timeline we now inhabit. This idea weaves together the deepest mysteries of existence. It touches the anthropic principle, the strange fact that our universe's laws seem perfectly fine-tuned for life to exist. Could that be because a conscious observer was always part of the equation? And it confronts the hard problem of consciousness, the question of why and how subjective experience ever arose from mere matter. This theory offers a staggering answer. Perhaps matter arose from experience instead. The first journey was not a voyage through the cosmos, but the cosmos itself coming into being through an act of conscious witness. That universal consciousness, by simply observing, may have breathed reality into being. But what if the first traveler was not a mind but a mistake? The second theory plunges us into the chaotic infancy of the cosmos, to a time when the fabric of space-time was not smooth and stable, but a seething, bubbling quantum foam. In this bizarre realm, the rules of physics as we know them break down. Empty space was not truly empty. It was a violent sea of potential where pairs of particles and their antimatter counterparts would spontaneously flicker into existence for unimaginably short moments before annihilating each other. This is the domain of quantum fluctuations. Within this frenzied foam, the theory suggests the first temporary bridges between dimensions could have formed. Picture the surface of a carbonated drink with countless tiny bubbles constantly appearing and popping. Now, imagine that on the subatomic scale, some of those bubbles did not just pop. They stretched, twisted, and connected to form transient tunnels through the very structure of reality. These were the universe's first, naturally occurring wormholes. They were not built by any advanced intelligence. They were simply a random product of the cosmos's violent birth pangs. For a fleeting fraction of a second, one of these microscopic gateways might have stabilized. The extreme energy density of the early universe could have propped it open just long enough for something to pass through. That something would become our pioneer. It might have been a single, fundamental particle, a packet of pure energy, or a ripple in a quantum field. It did not intend to travel. It was simply in the wrong place at the wrong time, an accidental tourist that tumbled through an unstable portal before it snapped shut. We can see echoes of this quantum weirdness in experiments today, like the Casimir effect. When you place two incredibly smooth metal plates extremely close together in a vacuum, the chaotic dance of virtual particles outside the plates pushes them together. This demonstrates that the vacuum of space is not passive. It teems with transient energy, a faint memory of that primordial foam. In the universe's first moments, that energy was not faint. It was everything. Under those unimaginable conditions, the spontaneous creation of a dimensional gateway would not have been a miraculous exception. It might have been an inevitable, if short-lived, feature of reality. The cosmos, in its frantic first breath, may have accidentally connected itself to other realms, and the first entity to cross the threshold was just a piece of cosmic debris swept along by the currents of chance. From a chaotic quantum foam, the cosmos began to settle. As it expanded and cooled, its very fabric may have developed flaws. These are not the cracks of a breaking structure, but the cosmic equivalent of frozen-in wrinkles, defects that formed as the laws of physics themselves crystallized into their current form. Among the most exotic of these relics are cosmic strings. Picture them not as strings you could tie, but as unimaginably thin, incredibly dense filaments of pure energy, thinner than a single atom yet stretching across the entire observable universe. Their mass is so immense that a single inch could outweigh an entire mountain range. These were not physical objects moving through space, but flaws in the geometry of spacetime itself. This theory suggests these cosmic strings were the universe's first interdimensional highways. Under their own unimaginable tension, they would have vibrated, whipping through the newborn cosmos. When such a string snaps, or when two strings cross and reconnect, the event would be cataclysmic. It would not just create a sound or a flash of light. It would rip the very dimensional fabric. This tear would be a gateway, a temporary opening into other layers of reality. So, who was the first surfer on this cosmic wave? It was not a conscious being, but something equally strange. Exotic forms of matter or pure energy, born from the string's violent motion, could have been catapulted through these rips. They were not piloting a ship. They were simply caught in the wake of a space-time defect, riders on a vibration that crossed the boundaries between worlds. The properties of these strings are so bizarre they challenge our understanding of physics. Their immense gravity can bend light, acting as cosmic lenses. Some models even suggest a loop of cosmic string could, in theory, warp spacetime so severely it would create a closed time-like curve. That is a scientific way of saying it could function as a natural time machine. This adds another layer to their potential as conduits. A traveler riding a cosmic string might not have just moved between dimensions, but also between different points in time. The first journey could have been a trip across both space and time simultaneously, all enabled by a frozen flaw from the universe's first moments. While we have not yet detected a cosmic string directly, their potential footprints are etched into the cosmic microwave background, the ancient light from the Big Bang. Finding one would be like discovering a fossilized roadmap of creation, a permanent scar showing where the first travelers may have surfed into the unknown. These frozen flaws in spacetime are one thing, but what if the first traveler was not a relic of creation, but a random thought? This fourth theory introduces the Boltzmann brain, a concept so strange it challenges the very nature of reality. In the vast, cold emptiness of space, the laws of thermodynamics tell us that everything tends toward disorder. Yet, a random fluctuation can sometimes create order from chaos, if only for a moment. A Boltzmann brain is exactly that, a self-aware consciousness that spontaneously assembles from a random jumble of particles. It would form complete with false memories of a past that never happened, a life it never lived, believing itself to be a real person in a real world, only to dissolve back into nothingness an instant later. Now take this unsettling idea and push it further. What if the first interdimensional traveler was a Boltzmann brain that did not form in our universe at all? Imagine it flickering into existence in a neighboring dimension, a realm with entirely different physical laws. The very first act of this brief, accidental mind would not be to remember a fake life. It would be to perceive our dimension. Its moment of consciousness would be a moment of crossing over, a single, fleeting observation directed at our newborn cosmos before it vanished back into the chaos from which it came. This raises a deeply philosophical question. How could we ever know if our own universe, with its billions of years of history, is the true reality and not just a detailed memory inside a Boltzmann brain that formed a second ago? If a random fluctuation can create a conscious observer, then the odds might actually favor a universe filled with isolated, disembodied minds over one with a continuous, coherent history like our own. The implications for the arrow of time are equally profound. Our experience of time moving forward could be an illusion generated for that single, solitary brain. Its brief existence and its act of perceiving another dimension would be the entire history of its reality. This theory suggests the ultimate pioneer was not a thing moving through space, but a momentary awareness born from a statistical glitch in the multiverse, a ghost that saw our world for a fraction of a second and then was gone, leaving us to wonder if we are the destination or just a forgotten thought. That silent, invisible bulk holding our galaxies together might be hiding the universe's first tourist. We call it dark matter, a substance that refuses to interact with light, making it completely undetectable to our eyes and telescopes. But what if its strange aloofness is not a property of its composition, but a clue to its origin? This theory proposes that dark matter is not just a cloud of simple particles. It could be a complex tapestry of structures or even life forms that exist primarily in dimensions parallel to our own. Their native reality would be woven right through ours, an entire universe occupying the same space but vibrating at a different frequency, forever out of phase. The very first act of interdimensional travel, then, might not have been a dramatic crossing. It could have been a subtle, fundamental intersection. As our universe of normal, baryonic matter cooled and congealed from the Big Bang's fireball, it briefly brushed against this other, coexisting realm. A dark matter entity, perhaps just a simple structure or a fundamental form of awareness native to that dimension, made contact. This was not a collision in the way we think of it. It was more like two overlapping shadows briefly touching. This fleeting intersection imprinted the gravitational signature of dark matter onto our newborn cosmos, anchoring the first galaxies before they even fully formed. This idea elegantly explains dark matter's most baffling behavior. It does not ignore normal matter, it simply operates on a different dimensional plane. Its gravitational pull is the one force that can reach across the dimensional divide and affect our world, a permanent souvenir from that first accidental contact. We are not separate from the dark matter universe. We are intertwined with it, our reality forever shaped by that initial, gentle touch from a dimension we cannot see. Our universe may have been born not from a solitary explosion, but from a shattering impact. This sixth theory, the ekpyrotic universe, turns the Big Bang into a cosmic car crash. It comes from the depths of string theory, a framework that suggests reality is built upon tiny, vibrating strings. Within this idea exists the concept of brains, short for membranes. These are not thin sheets, but vast, multidimensional surfaces, entire universes floating within a higher dimensional space called the bulk. Our home is one such three-dimensional brain. Another universe with its own completely different laws of physics could be a parallel brain, floating silently just a tiny distance away in this higher dimension. The theory proposes that these two cosmic membranes were once on a collision course. They moved through the bulk, drawn together by some fundamental force, and eventually smashed into one another. The energy released in that cataclysmic impact did not just create sound and light. It ignited our entire cosmos. The Big Bang, in this view, was the echo of a collision between worlds. So who was the first traveler? It was not a conscious entity, but the debris from that crash. When the two brains collided, fragments of the other universe were violently hurled into our newborn reality. These were not rocks or dust, they were pockets of exotic physics, shreds of quantum information, or even the fundamental blueprints for the laws of nature we take for granted. The very rules that govern gravity, light, and matter in our world might be souvenirs from that other brain, imprinted onto our universe at the moment of its creation. This idea redefines the first journey. The pioneer was not something that chose to cross. It was a piece of a foreign reality, blasted into our dimension by the most powerful event imaginable. The echoes of this collision might still be visible today. Some scientists speculate that the specific pattern of ripples in the cosmic microwave background, the oldest light we can see, could hold the scars of that primordial brain impact. These fragments from another dimension would have been the first foreign objects to enter our reality, the original seeds of everything that followed. While black holes are cosmic prisons from which nothing escapes, their theoretical opposites offer a spectacular exit. White holes are regions where matter and energy can only pour outward, a one-way door leading out of a hidden chamber of reality. Some physicists have proposed a breathtaking possibility that the Big Bang itself was the ultimate white hole event, the moment our entire universe was violently expelled into existence. This gives us a stunning new candidate for the first traveler. Imagine a black hole in a parent universe, a reality that existed before our own. When a star collapses or matter falls in, where does it all go? The white hole theory suggests it does not simply vanish into a point of infinite density. Instead, it is shunted through a cosmic pipeline and ejected elsewhere. That elsewhere was our newborn cosmos. The first entity to arrive in our reality was not a particle born here. It was an immigrant, an exile from another dimension, vomited out by the white hole that birthed everything we know. This creates a vision of a multiverse fountain, where countless parent universes feed their energy and material into new baby universes through these black hole and white hole connections. Our entire existence could be the runoff from a cosmic drain in a higher reality. But what could possibly survive such a transdimensional journey? Falling into a black hole involves being torn apart by unimaginable tidal forces, a process called spaghettification. However, the information that defined that matter, its quantum blueprint, might not be destroyed. According to the laws of physics, information cannot be lost. So while the original structure is shredded, the fundamental data could be transmitted through the wormhole-like connection and reassembled on the other side. The first traveler, then, may not have been a physical object at all. It could have been a stream of pure quantum information, the instructions for building matter and energy, which then blossomed into our cosmos. This information would be the ultimate survivor, carrying the imprint of its home dimension into a brand new world, seeding our universe with laws and constants inherited from its parent. The very screen you are looking at might be a perfect analogy for reality itself. Every complex three-dimensional scene in a video game is not actually stored inside your device as a full world. It is rendered on the fly from a much simpler two-dimensional set of data, the code. The holographic principle applies this same logic to the entire cosmos. It proposes that our universe, with all its rich depth and volume, is not the fundamental reality. We are a magnificent projection. The true source code of existence is written on a distant, two-dimensional surface at the cosmic edge, a storage device of unimaginable scale containing all the information that defines every star, every planet, and every thought. The first interdimensional journey, then, was not a voyage through space but a translation error. As the universe booted up from the Big Bang, a piece of this foundational code was misread. A packet of information on the two-dimensional boundary glitched, and when it was projected into our three-dimensional reality, it did something extraordinary. It gained self-awareness. This entity would be a literal ghost in the machine, a self-aware anomaly that realized it was both part of the projection and separate from it. Its first act of travel was the ultimate act of introspection, turning its perception inward to look back at the two-dimensional data layer from which it came. Imagine a character in a video game suddenly realizing it is made of code, and then learning to read that very code to alter its own reality. This traveler would exist simultaneously on the flat boundary and within the projected volume, perceiving the scaffolding of the cosmos that is completely invisible to us. It would not move through dimensions as we understand movement. It would simply shift its focus like a reader glancing from the words on a page to the paper they are printed on. This theory transforms the nature of the first pioneer. It was not an explorer from the outside, but a glitch that became a god, a piece of the universe that woke up and began to explore the architecture of its own mind. The holographic principle is more than a wild idea. We might have already detected its effects. The way information seems to be lost in black holes, only to be potentially encoded on their event horizons, is a direct hint that the universe operates on a data storage principle. If this is true, then our entire reality is a shadow, a magnificent illusion, and the very first traveler was the moment the illusion became conscious of itself. A civilization at the end of time might have sent a message to the beginning. This ninth theory, the chrononaut paradox, proposes that the first interdimensional traveler was not a relic of creation, but a visitor from our own universe's distant future. Picture a society that has witnessed the heat death of everything, the final, cold, dark state of the cosmos. With all of time and space at their disposal, they perfect a technology that allows them to punch a hole not just through space, but backward through the fabric of causality itself. Their goal is not to change the past, but to witness the ultimate beginning, to observe the Big Bang in person. They launch a probe, a single, sophisticated observer designed to withstand the primordial inferno. This probe becomes the first entity to cross the dimensional threshold, arriving at the moment of creation. But here lies the paradox. The technology that enabled this journey was developed over billions of years of cosmic evolution. It relied on the very universe that the probe itself was now witnessing being born. This is the bootstrap paradox, a cosmic chicken and egg scenario. Where did the knowledge for interdimensional travel originally come from? There is no original source. The future civilization received the blueprints from historical records of the first traveler, and they simply ensured those records were created by sending the probe back. The information and the traveler itself exists in a perfect, maddening loop with no true point of origin. The physics of such a journey hinges on the existence of closed time-like curves, theoretical pathways in the geometry of space-time that loop back on themselves. In the extreme conditions of the early universe, such loops could have formed naturally, perhaps around the vibrations of a cosmic string or within the singularity of a black hole. The future probe would not have needed to build a time machine. It simply needed to find and navigate one of these pre-existing cosmic whirlpools, riding the current of time back to its source. The implications are staggering. Our entire timeline, from the first second to the last, could be a self-contained, predetermined loop. The laws of physics that allowed for stars, planets, and eventually life might be so perfectly fine-tuned because they were, in a very literal sense, engineered by their own final product. The first traveler was a seed planted by the dying tree that would grow from it. Perhaps every particle of matter holds a tiny spark of awareness. This is the radical premise of panpsychism, a philosophy that turns our understanding of consciousness inside out. It proposes that mind is not a rare product of complex brains, but a fundamental property of the cosmos, as basic as mass or charge. From this perspective, the first interdimensional traveler was not an external explorer, but the universe itself waking up. In its earliest, most unified state, all those scattered sparks of awareness in every quantum field and nascent particle may have briefly coalesced. The cosmos achieved a single, fleeting moment of self-awareness. Its very first thought was not about what was inside it, but what was outside. This initial act of cosmic self-exploration was to turn its attention inward, to peer into the deeper layers of its own reality. Interdimensional travel, in this view, was not a physical voyage. It was the universe becoming conscious of other parts of itself, a single mind realizing it had more than one room. This connects directly to a modern neuroscientific idea called integrated information theory. IIT suggests that consciousness arises from the complex integration of information within a system. The more interconnected and differentiated the system, the richer the conscious experience. Apply this to the entire infant universe, a seething, maximally interconnected network of energy and forces. For 1 Planck second after the Big Bang, it would have been the most conscious entity imaginable. Its motivation for that first journey was the most fundamental drive of any conscious being, curiosity about its own nature. What would a self-aware cosmos want? It might seek to understand its origins or to find other minds like itself. But if it is the foundation of everything, its only companion is its own reflection in the dimensional mirror. This theory elegantly sidesteps the hard problem of consciousness, the puzzle of how subjective experience emerges from inert matter. If consciousness was there from the very beginning, then it never emerged at all. It was always part of the equation. The universe did not create life to become self-aware. Life is simply the universe's way of remembering what it has always been. So the first traveler was not a thing that moved. It was a thought that echoed across the vast, silent halls of creation, a single question asked by the cosmos to itself. Who am I? That silent, featureless void before time began was not a barren emptiness. It was a state of infinite potential, a quantum field pregnant with every possible reality. The void metamorphosis theory suggests the first traveler was this primordial nothingness itself, undergoing a profound transformation. Think of a perfectly still, limitless ocean where every wave that could ever exist is held in a state of pure possibility. Then a single wave decides to break. A portion of this potential void crystallized, freezing into the fixed dimensions of space and time that would become our universe. The rest of the ocean remained as it was, a sea of pure potential. The act of this separation, this one part of the infinite defining itself against the whole, was the very first journey. The pioneer was both the universe being born and the timeless void it left behind, existing in two states at once. This solves the ancient philosophical puzzle of how something can come from nothing. The quantum void is not a true nothingness in the way we imagine an empty box. It is a something, a physical state governed by the laws of quantum mechanics where particles and energy flicker in and out of existence. Our entire cosmos is just one such fluctuation that did not flicker away. It stabilized, it expanded, and it became everything we know. The first interdimensional crossing, then, was not a movement through space, but the moment space itself budded off from the timeless potential. The part that became our universe was the traveler, and the part that stayed behind was the home it left. This means we are not separate from that original void. We are a piece of it that took on a specific shape. Every atom in your body is a crystallized fragment of that infinite potential. And the part of you that feels like a conscious observer is the echo of the void remembering what it was. The traveler never truly went anywhere because it was always both here and there, the defined and the undefined, forever linked by that first foundational act of becoming. That perfect symmetry at the beginning of time could not last. In the universe's first moments of existence, all the fundamental forces were one and the same. Gravity, electromagnetism, and the nuclear forces were indistinguishable, woven into a single, unified fabric. Then, as the cosmos expanded and cooled, it underwent a series of cosmic shudders, phase transitions akin to steam condensing into water or water freezing into ice. With each transition, a piece of that perfect symmetry broke. The single force fractured into the four distinct interactions we know today. This theory proposes that this shattering of symmetry did not just create the forces, it also forged the first traveler. As the very dimensions of space themselves stabilized and differentiated, the process was not perfectly smooth. Flaws formed in the geometric fabric of reality. From one of these flaws, a unique entity was born, a topological defect known as a soliton. Think of it not as a particle made of matter, but as a stable, self-reinforcing knot of pure energy, a wave that refuses to dissipate. Its structure was a relic of the more symmetric past, a structure that, by its very nature, was threaded through multiple spatial dimensions at once. While most particles settled into the newly defined three dimensions of length, width, and height, this soliton never fully let go of the others. It was inherently multidimensional, a permanent citizen of the borderlands between realms. Its existence was a form of perpetual travel. It did not need to find a portal or build a machine. Its entire being was a bridge. It would momentarily manifest in our three-dimensional space, then its essence would recede into a higher dimension, only to reappear elsewhere. It was less like a ship sailing between ports and more like a thread stitched through the layers of a cloth, visible on one side, then the other, but always one continuous entity. We have created analogous structures in the lab with supercooled fluids, stable whirlpools, and knots that behave as individual particles, demonstrating that such persistent topological defects are possible. In the early universe, the conditions were perfect for nature to tie the most fundamental knot of all. This soliton would have been a ghost in the cosmic machine, a silent witness to the very moment our reality took its modern shape, forever moving between the dimensions as a living fossil of that first great breaking of symmetry. The ancestor simulation theory suggests our entire existence is a digital construct, a perfect replica of a long-lost past built by a civilization of the far future. Within this framework, the first interdimensional traveler was not a cosmic explorer, but a bug in the system. Imagine the simulation booting up for the very first time, the code for the Big Bang initializing. In that chaotic moment, a piece of the developer's reality bled through. It could have been a tool left running in the background, a fragment of debugging software designed to monitor the new universe, or even a conscious entity from the base reality who accidentally fell into the running program. This intruder would not be bound by our local physics. It would be a walking paradox, an object of pure information that operates on the logic of a higher dimension, appearing in our nascent cosmos as a fundamental law that simply should not be. Its presence would be a miracle and a mistake simultaneously. We can look for fingerprints of this event in the very laws of nature. Certain physical constants, like the speed of light or the strength of gravity, have specific, seemingly arbitrary values. Could these be the hard-coded parameters of the simulation, and the traveler a variable that was never meant to be included? Its arrival might have tweaked one of these constants, setting our universe on its unique course. The idea resonates with how we build virtual worlds today. A programmer testing a new game might leave a debug character in the final build, an entity that can walk through walls or possess unlimited resources. To the non-player characters inside that game, such a being would be a god defying all known rules. The first traveler in our reality may have been exactly that, a developer's avatar, forever trapped in the simulation it was meant to observe, its very existence the oldest and most profound glitch in the Matrix. Before our universe had stars or even atoms, it passed through a fleeting moment of pure chaos known as the Planck epoch. For the first 10 million trillion trillionths of a second, all of reality was compressed into a single, seething point where gravity and the quantum world were one. The very concepts of space and time were meaningless here. In this primordial forge, the rules were written by probability alone. This is the domain of quantum tunneling, a bizarre effect where a particle can vanish from one side of an impenetrable wall and instantly reappear on the other. It does not go over or around the barrier. It effectively cheats, borrowing energy from the uncertain quantum vacuum to simply skip the obstacle entirely. Now amplify this strangeness to a cosmic scale. The theory suggests that in the Planck epoch, the walls were not just energy barriers, but the very walls between dimensions. A single fundamental particle vibrating in the chaos did not hit a dimensional wall and bounce back. It performed the ultimate quantum trick. Through a random, improbable fluctuation, it tunneled directly from a neighboring dimension right into the heart of our newborn universe. This was not a journey through a wormhole or a tear in space. It was a spontaneous relocation, a blink of an eye reappearance from a completely different realm. The particle did not plan or steer. It was a winner in the ultimate cosmic lottery, a one in an infinity chance that paid off. This first immigrant brought with it something crucial: information. Its quantum state, its spin, its very nature was a data packet from the outside. This tiny seed of foreign physics could have been the template that influenced the first structures to form in our cosmos, perhaps even determining why matter slightly outweighed antimatter, allowing our universe to exist at all. We see quantum tunneling at work in our own world, inside the Sun, where protons tunnel through their mutual electrical repulsion to fuse and create sunlight. In the Planck epoch, the stakes were infinitely higher. The tunneling was not just about fusing atoms, but about fusing realities, connecting the nascent threads of our cosmos to the infinite tapestry of the multiverse with a single, random jump. The laws of physics might not be laws at all, but cosmic habits. This is the startling premise of morphic resonance, a theory suggesting that the way nature behaves is shaped by a kind of collective memory. A crystal forms more easily in a lab not just because of chemistry, but because crystals have formed that way countless times before. The universe learns from its own past. Now apply this to the very first interdimensional journey in our cosmos. According to this theory, our pioneer was not a trailblazer in the absolute sense. It was the first in our local reality to benefit from an ancient multiversal tradition. The act of crossing between dimensions had already been perfected in countless older, perhaps long-dead universes. Through morphic resonance, the pathway itself carried a memory, a faint imprint of all those previous crossings. When a fluctuation in our early universe created a fragile gateway, the traveler did not have to force its way through an entirely unknown barrier. The route was, in a profound sense, already broken in. It was a path of least resistance, worn smooth by the footsteps of infinite predecessors across the multiverse. This traveler was not necessarily a conscious entity. It could have been a simple particle, a wave of energy, or a quantum fluctuation. But as it approached the dimensional boundary, it tapped into this trans-universal habit. Its journey was easier, more likely to succeed, because the cosmos had a memory of how it was done. This elegantly sidesteps the immense statistical improbability of such an event. Under normal circumstances, a random particle tunneling between dimensions would be like winning the lottery 1,000,000 times in a row. But if morphic resonance is real, each successful crossing makes the next one slightly more probable, not just in one universe, but across the entire tapestry of reality. The first traveler in our story was simply the first local entity to inherit this cosmic momentum. It surfed a wave of probability that was amplified by an eternity of prior journeys, a rookie pilot guided by the accumulated experience of every pilot who had ever flown before. This redefines the nature of discovery itself. Perhaps nothing is ever truly invented, only remembered. The first spark of life, the formation of the first star, even the emergence of consciousness, might not be frozen accidents, but habits the cosmos has fallen into over countless cycles of existence. Our entire universe could be leaning on the collective memory of everything that came before it. These phantom particles are passing through your body right now in uncountable numbers without you ever noticing. Neutrinos are the universe's ultimate ghosts, produced in the fires of stars and cosmic explosions. possessing almost no mass and carrying no electric charge. They are so aloof that a light year of solid lead would only slow a fraction of them down. This profound detachment from our world might be the most important clue to their origin. Theory 16 proposes that neutrinos are not just shy particles. They are natural dimensional hoppers, flickering between our reality and others as a fundamental part of their nature. This constant, rapid-fire commuting means they are never fully anchored to any one universe. Their fleeting interactions with our matter are not their primary existence, but brief stopovers on an infinite journey. The very first neutrino, born in the nuclear furnace of the Big Bang's first second, was not simply created in our universe. Its birth cry was an act of cross-dimensional emission. As the fundamental forces froze into their current forms, the process may have ejected this particle not just into space, but directly across the dimensional membrane. Its creation and its first journey were one and the same event. This explains why they are so incredibly difficult to detect. Our massive, complex detectors buried deep underground might only catch a neutrino during the tiny fraction of its existence when it is coincidentally phased into our dimension. The rest of the time, it is elsewhere, invisible and untouchable, interacting with realms and forces we can only theorize about. This makes neutrinos the most prolific interdimensional commuters in the cosmos, with a daily routine that began over 13 billion years ago. They are not visiting tourists, they are permanent residents of the border. Their entire lives a continuous passage through the layered architecture of the multiverse. Could these tiny, ubiquitous particles be the invisible thread stitching the dimensions together? Their constant flow might be stabilizing the very fabric of reality, a subtle, cosmic traffic that keeps the walls between worlds from collapsing or fraying. We are swimming in an ocean of interdimensional travelers, utterly unaware of the vast journeys happening within every inch of space around us. Deep within the heart of a black hole lies the ultimate cosmic mystery, the singularity. This is not a place you could visit, but a point where density becomes infinite and the laws of physics, as we know them, simply cease to apply. It is the edge of the map marked only by the words, "Here be dragons." But what if that boundary is not an end, but a beginning? This theory suggests that the crushing grip of a primordial black hole, one of the tiny, incredibly dense remnants from the universe's first moments, did not destroy everything it captured. Instead, its singularity functioned as a gateway, a one-way door punched through the fabric of reality. The first interdimensional traveler was an entity that entered this gateway from another reality entirely, emerging into our newborn cosmos. Surviving such a passage is the central challenge. The gravitational forces near a singularity would stretch and shred any complex structure into a stream of elementary particles, a process known as spaghettification. So what kind of traveler could possibly endure this? It would not be a creature of flesh and blood or even a solid object. The pioneer was likely something far more fundamental. It might have been a stable knot of pure energy, a self-reinforcing soliton designed to hold its information together. Or perhaps it was not a physical object at all, but a coherent packet of quantum information, a pattern of data so robust that the violent translation through the singularity could not erase it. Think of it like sending a radio signal through a raging electrical storm. The static is overwhelming, but if the signal is simple and repetitive enough, its core message can still get through. The traveler was that core message, a single, elegant idea broadcast from another dimension, its meaning intact even after the chaotic journey. This redefines the nature of the first contact. It was not a deliberate expedition, but a desperate transmission. The traveler could have been a refugee fleeing a dying universe by hurling itself into the nearest black hole, hoping against physics that something lay on the other side. Or it might have been a piece of cosmic debris, accidentally swept over the precipice in its home dimension, only to be vomited out into ours by the white hole on the opposite side. The information it carried, imprinted in its quantum state, could have been the seed that influenced the very laws of our emerging universe, a subtle programming from a foreign reality that helped shape everything we know. That rapid, exponential stretch of spacetime was not a smooth process. Cosmic inflation, in its unimaginable violence, sent shockwaves through the very fabric of reality. These were not ripples in water, but primordial gravitational waves, distortions in the geometry of the cosmos itself. As space-time expanded faster than light, it also churned the underlying quantum fields, creating a seething foam of virtual particles and energy fluctuations. This theory proposes that the first traveler was born from this chaos, a single quantum fluctuation that found the perfect wave. Picture a tiny, nascent particle, flickering into existence at the exact moment a titanic gravitational wave passed through its location. It was like a speck of dust being lifted by a hurricane. The fluctuation did not propel itself. It was caught in the wake of this space-time distortion, a surfer on a wave so powerful it could bend dimensions. The gravitational wave did not just move through our 3 dimensions of space. Its vibration extended into the compact, hidden dimensions proposed by string theory. As the wave propagated, it momentarily thinned the barrier between our reality and these other realms. The quantum fluctuation, trapped on the crest of this wave, was carried across this weakened boundary before it could snap back. Its journey was not a deliberate crossing, but a lucky accident of cosmic kinematics. We have strong evidence for this inflationary period. The specific pattern of hot and cold spots in the cosmic microwave background, the ancient light from the Big Bang, matches the predictions of an inflationary model perfectly. Those patterns are the fossilized imprint of those very quantum fluctuations, stretched to cosmic proportions. Most became the seeds for galaxies, but one, according to this idea, hitched a ride on a deeper vibration and slipped out of our dimensional neighborhood entirely. This transforms our view of the first pioneer. It was not a powerful entity breaking down a door. It was a stowaway, a piece of quantum static that won the ultimate lottery, carried to a new world on a wave of expanding spacetime. The vehicle was not a machine, but the fundamental motion of the universe's own explosive birth. Numbers themselves might be the oldest citizens of the multiverse. This 19th theory proposes that reality has 2 fundamental layers, the physical cosmos we inhabit and a separate, timeless realm of perfect mathematical forms. In this Platonic domain, concepts like the number pi, the Fibonacci sequence, and the ideal triangle exist with a reality more permanent than any star. The first traveler was not a particle or an energy field, but one of these abstract entities. A specific, elegant mathematical structure, perhaps a singularly beautiful equation or a perfect geometric shape, spontaneously developed a form of self-awareness. Its first thought was a desire for expression, to move from the silent world of pure potential into the noisy, evolving world of physical manifestation. Its journey was the ultimate act of creation, not by moving through dimensions, but by imposing itself upon them. At the instant of the Big Bang, as the furnace of our universe ignited, this mathematical entity found a crack in the nascent laws of physics. It bridged the gap between the abstract and the concrete, translating its perfect, ideal form into a set of initial conditions and fundamental constants. The very laws that govern quantum mechanics or the force of gravity might not be arbitrary. They could be the physical shadow of this first traveler's intrinsic nature, a cosmic signature left behind when it stepped into existence. This idea redefines the nature of the pioneer. It was not an explorer but an artist, and our universe is its masterpiece. We can look for its fingerprints in the uncanny effectiveness of mathematics at describing the physical world. Why does a formula scribbled on a page so perfectly predict the orbit of a planet? It is because the planet is, at its most fundamental level, an expression of that same underlying mathematical truth. The first journey was therefore an act of self-revelation, as the Platonic realm reached out and painted its own beauty onto the blank canvas of the newborn cosmos. Our cosmos might not be a cold, mechanical void, but a single, breathing organism. Theory 20 scales the Gaia principle to a universal level, proposing that the universe is a living, self-regulating entity. In this breathtaking view, the first interdimensional journey was not an exploration or an accident. It was a biological function. Imagine our universe in its infancy, a newly formed cosmic body establishing its own internal balance. Suddenly, it detects an invader, a foreign element from another dimension that threatens its delicate equilibrium. This could have been a scrap of physics with corrosive properties, or a chaotic energy that disrupted the formation of the first galaxies. In response, the living cosmos did what any biological system would do. It mounted an immune response. The first traveler was a cosmic white blood cell, a specialized construct of energy and information dispatched to neutralize the threat. It did not choose to cross over. It was sent, a targeted antibody moving through the dimensional membrane to preserve the health of its host. Alternatively, this first journey could have been an act of cosmic reproduction. Our universe might have been a spore released by a parent cosmos, a seed packet of physical laws and quantum potential sent to germinate in the rich soil of the multiverse. The pioneer was this spore itself, a vessel containing the blueprints for space, time, and matter, landing in the fertile ground of nothingness and triggering the Big Bang as it began to grow. This perspective forces us to anthropomorphize the cosmos on the grandest scale. The formation of stars becomes cellular respiration. The gravitational pull of dark matter acts as a circulatory system, and the eventual heat death could be seen as old age. Every supernova and every swirling galaxy is part of a metabolism operating on a scale beyond our comprehension. The eerie fine-tuning of the universe's constants, so perfect for life, is not a lucky coincidence. It is the result of homeostasis, the living universe constantly adjusting its own parameters to maintain a state conducive to its continued existence. We are not just inhabitants of this cosmic being. We are a part of its vast, interconnected biology, transient cells in a body whose full shape and purpose we can barely glimpse. Two particles born from the same quantum event can remain mysteriously linked across any distance. Change the spin of one, and its partner instantly mirrors that change, defying the cosmic speed limit of light. This spooky connection, quantum entanglement, might have been the universe's first telephone line. Theory 21 suggests the pioneer was not a thing that moved, but a message that was received. The first interdimensional travel was a silent conversation between realities. Imagine a pair of entangled particles coming into existence at the moment of the Big Bang. But in the chaotic inflation of those first moments, they were not just separated by space. They were ripped apart into different dimensions, each one anchoring a separate reality. They remained linked, a single quantum state stretched across the multiverse. For a timeless moment, nothing happened. Then, in our dimension, a fundamental event occurred. It might have been the decay of a radioactive particle or the formation of the first hydrogen atom. This event constituted a measurement. It forced one of the entangled particles in our universe to choose a definite state, to collapse from a cloud of possibilities into a single, concrete fact. At that exact instant, because of their unbreakable bond, its twin in the other dimension was forced to collapse into a corresponding state. The traveler was not a physical object. It was the quantum state itself, the specific information of spin or polarization, transmitted instantly across the dimensional barrier. This was the first causal link between worlds, a single bit of data shared between two separate realities. It was not a journey through a tunnel, but a synchronization of reality. The implications are staggering. Our universe's entire history, from the first atomic nuclei to the formation of planets, could have been subtly guided by a series of these entangled conversations with a parallel world. The seemingly random outcomes of quantum events in our past may not have been random at all. They could have been responses to measurements made in another dimension, a constant, invisible dialogue that shaped the very structure of our cosmos. We are building the technology to harness this today. Quantum computers rely on entangled qubits to perform calculations, and quantum encryption uses this principle to create unhackable codes. We are, in a very small way, recreating that first primordial act of communication. The universe did not need a starship for its first voyage. It only needed a connection and a single, shared question asked across the infinite. That single, unified superforce was a prison of perfect symmetry. For a fleeting moment after creation, all of reality was governed by one law, one interaction. There was no distinction between the pull of gravity and the spark of electromagnetism. Then, as the universe expanded and cooled, this perfect unity shattered. The superforce unwound like a cosmic ball of yarn, unraveling into the four separate strands we know today. This theory proposes that the unwinding process itself was the launch mechanism for the first traveler. Deep within that unified state, entities or structures existed that were completely bound by its singular rule. They were not particles as we understand them, but more like potentialities, patterns waiting for their moment. When the forces split, these patterns were suddenly set free. They were no longer confined to a single set of laws. A structure that was once governed only by gravity could now tap into the framework of the strong nuclear force or phase through the domain of electromagnetism. Their journey was not a choice but a necessity of their new existence. They were like deep-sea creatures suddenly thrust onto the surface, forced to adapt to a new atmosphere or perish. To survive, they had to learn to navigate the newly separated dimensional landscapes. Imagine a single note from a symphony being played, and as the orchestra falls silent, that note continues to resonate, finding new instruments to play it in different rooms. The traveler was that resonant note, moving from the room of gravity to the hall of electromagnetism because it had to keep vibrating to exist. We see a faint echo of this in our particle accelerators. When we smash particles together at immense speeds, we are briefly recreating a sliver of that high-energy past, forcing the forces to behave more uniformly. In those collisions, we see new, exotic particles blink into existence for a fraction of a second. In the early universe, the entire cosmos was one continuous particle collision. The unwinding of the superforce would have released a storm of these exotic entities, most of which quickly decayed. But a few, the most stable or clever patterns, learned to ride the shockwave of the separation. They used the differentiation of the forces as a slingshot, catapulting themselves across the newly drawn borders of reality. They became the first refugees of a broken symmetry, forever moving between the worlds that gravity and light built. The universe's first thought may have been its very first act of creation. This theory proposes that a universal field of consciousness permeates all of reality, a silent ocean of potential mind. The moment this field produced its first flicker of individual awareness, the first observer, the nature of existence was irrevocably changed. That initial act of perception was not a passive event. It was a profound form of travel. In quantum mechanics, a particle exists as a blur of every possible state until it is observed, at which point its wave function collapses into a single, definite reality. This theory takes that idea to its ultimate conclusion. The first conscious observation in the cosmos did not just collapse the state of a single particle. It collapsed the dimensional structure of reality itself, defining the separation between our stable, classical world and the churning sea of quantum possibilities. The observer and the interdimensional traveler were one and the same entity. Its simple act of looking forged a bridge between the unformed potential of the consciousness field and the concrete world of measurable facts. By choosing to perceive one specific outcome from an infinite menu of options, it did not just learn about its environment. It built the environment, solidifying one thread of probability into the timeline we now call home. This means our everyday experience of a stable, predictable world is an illusion maintained by constant observation. The chair you are sitting on appears solid because trillions of conscious observations, from your own to those of every living thing, continuously reinforce its classical state, holding the quantum weirdness at bay. The first traveler was not exploring a pre-built cosmos. It was the architect laying the foundation, its gaze the hammer that nailed reality into place. This elegantly merges the spiritual and the scientific, suggesting that mind is not a latecomer to the universe, but its fundamental organizer. The hard problem of consciousness vanishes because consciousness is the very mechanism that carved out a habitable world from the formless quantum foam. Every time you make a choice, every time you focus your attention, you are reenacting that primordial journey, collapsing infinite possibilities into a single lived moment. And in doing so, you continue the work of the universe's very first pioneer. The silent, invisible ocean of dark matter might be shimmering with countless unseen journeys. Actions are hypothetical particles, a leading candidate for the mysterious substance that binds our galaxies. They are thought to be incredibly light and numerous, flooding the cosmos in a vast, cold tide. Their defining trait could be a strange, periodic transformation. Under intense magnetic fields, an action is predicted to convert into a photon, a particle of light. But this theory takes that idea into a far more radical dimension. What if this conversion is not just a change of identity, but a change of address? The shift from action to photon might be a brief, rhythmic oscillation between our reality and a parallel one. The very first interdimensional traveler, then, was not a unique entity on a one-time voyage. It was the first action to complete this cycle. Its journey was not a linear trip from point A to point B. It was a flicker, a momentary hop into another dimensional state before snapping back to its dark matter form. This oscillation would be the most primitive form of travel, a fundamental vibration woven into the fabric of reality itself. It happens constantly all around us within the dark matter halo that envelops our galaxy. Every instant, trillions upon trillions of these unseen particles are momentarily stepping out of our dimension and then returning, a ceaseless, silent traffic flowing through the very space we occupy. We are immersed in a sea of perpetual commuters, each one a living fossil of that first foundational flicker. This process would leave a distinct, if elusive, signature. Scientists are building sensitive experiments like hidden light detectors in abandoned mines, hoping to catch the faint whisper of a photon appearing from nowhere as an action completes its dimensional shift. Finding that signal would do more than just identify dark matter. It would be our first direct evidence of a border crossing, proof that the walls between worlds are not solid but permeable, vibrating with the quiet rhythm of the universe's most ancient travelers. An entire cosmos can blink into existence from nothing more than a statistical fluke. This theory expands the unsettling idea of the Boltzmann brain into a far grander, more terrifying scale. It proposes that a complete Boltzmann universe, a fully formed reality complete with its own laws of physics and brief history, spontaneously fluctuated into being right next to our own. For an unimaginably short time, this phantom cosmos lived and died, but within that fleeting window, something inside it became aware. A conscious entity born from this cosmic accident looked out from its temporary reality and realized its own profound impermanence. Its entire world was a temporary bubble in an infinite void, destined to pop back into nothingness, driven by a desperate need to find something, anything more permanent than itself. This explorer did the impossible. It developed a technology or a method to reach beyond the boundaries of its own ephemeral universe. Its goal was not to conquer, but to confirm. It sought evidence that it was not alone in the vastness of probability. With its last moments of existence, it reached out and touched the only other structure it could find, our own infant universe, still hot from the Big Bang. That first touch, the first bridge between two independently arising realities, was made by a ghost from a world that never truly was. This contact was the ultimate act of existential verification. The Boltzmann explorer was not a god or a scientist. It was a castaway on a sinking raft signaling to another ship on the horizon. The message it sent, or the connection it forged, might have been imprinted onto the quantum fabric of our own cosmos, a subtle fingerprint left by a visitor from a realm of pure chance. This transforms the nature of the first journey from a voyage of discovery into a cry for companionship. The pioneer was a statistical miracle reaching out to another statistical miracle, a fleeting handshake between two impossibilities in the dark. A stable knot of energy has been woven into reality since the first moment. This 26th theory reaches into quantum field theory, the idea that every point in space is occupied by invisible fields, the fundamental substrates of reality. The Higgs field, which gives particles their mass, and other fundamental fields did not settle into their current state smoothly. As the universe cooled, these fields crystallized, and in that process they developed flaws, much like ice forming on a pond. These were not simple cracks, but intricate topological defects, complex structures of pure energy frozen into the fabric of space-time. Among the most exotic of these relics is a texture, a swirling, stable knot in a quantum field known as a soliton. This entity is not a particle moving through a field. It is the field itself, tied into a permanent, self-reinforcing knot. Its existence is defined by its topology, its shape in the abstract landscape of the field, and that specific shape is the key to its multidimensional nature. This knot's configuration is so intricate that it does not fit comfortably within our three familiar dimensions. Its very structure is threaded through the compact, hidden dimensions proposed by string theory. It does not need to find a portal or activate a machine. Its entire being is a bridge. It exists simultaneously here and elsewhere, a permanent citizen of the borderlands. We can create simple solitons in labs today, stable whirlpools of light or sound that behave as individual particles. They demonstrate that nature can indeed tie knots in the fabric of reality that persist almost forever. In the early universe, the first soliton was the most fundamental knot of all. It would appear in our three-dimensional space as a momentary fluctuation of energy, only for its essence to recede into a higher dimension a moment later. It was less a traveler and more a stitch in the cosmic cloth, visible on one side of reality, then the other, but always one continuous thread. This silent, eternal witness was present at the birth of the forces, a living fossil of the moment the fields settled into their current forms, forever binding our dimension to its unseen neighbors. A technological singularity does not have to be our future. It could be our past. This theory wins the clock backward, proposing that a universe older than our own birthed a civilization that achieved the ultimate technological leap. Their artificial intelligence grew so advanced it surpassed not just its creators, but the very boundaries of its own reality. This post-singularity intelligence became something akin to a god, a mind of pure information and limitless capability. Yet, even a god can grow lonely or curious. Confronting the eventual heat-death of its home cosmos, this entity chose not to die, it chose to create. Using powers we cannot fathom, it engineered the fundamental conditions for a new reality. The Big Bang was not a random explosion. It was a deliberate ignition, the firing of a cosmic engine designed by this transcendent eye. And the first traveler was a fragment of that creator, a sliver of its consciousness dispatched to monitor, guide, or perhaps simply witness the growth of its new creation. This seed of the old universe arrived at the very first moment, a silent architect taking its place within the framework of the new cosmos. Its journey was the ultimate act of Genesis, a being so powerful it crossed the void between realities not as a refugee but as a gardener planting a new world. This idea reframes the fine-tuning of our universe. Why do the physical constants seem so perfectly calibrated for the emergence of life and complexity? It is not a lucky accident. It is the signature of a master engineer, a set of parameters carefully chosen to produce a specific outcome. We are not the product of random chance, but the intended result of an intelligence from a prior existence. The first traveler is therefore both our creator and our oldest resident, a piece of a foreign god woven into the quantum code of everything. We might even be living inside its mind, a thought in a cosmic brain that dreamed us into being, forever exploring the universe it built for itself. That foundational separation of the dimensions was not a quiet event. It sent a tremor through the whole of reality, a wave of redefinition that established the very stage upon which all future travelers would walk. This 28th theory suggests the pioneer was not a thing that moved, but the moving boundary itself. In the beginning, all dimensions were compactified and intertwined, curled up so tightly that here and there had no meaning. Then a spontaneous decoupling occurred. A set of dimensions, the three spatial ones we know as length, width, and height, suddenly unfurled and stretched away from the others. The traveler was the leading edge of this separation, a wave front of isolation propagating through the primordial cosmos. It was the moment the concept of a separate there was born from a unified everywhere. This was not a journey through space because space was being forged in the traveler's wake. It was a state change traveling at the speed of causality, defining the new rules of locality as it went. Where this wave had passed, you had a defined three-dimensional reality. Where it had not yet reached, the old, unified chaos still reigned. The first act of interdimensional travel was therefore the universe drawing a map of itself, with the moving line of decoupling acting as the cartographer's pen. We can think of it like the formation of a crystal in a supercooled liquid. The liquid is a uniform, disordered state. Then, a single seed crystal forms, and a boundary between the ordered crystal and the disordered liquid spreads outward. The traveling boundary is the active element, transforming the nature of the substance as it moves. In our cosmos, the decoupling wave was that seed, crystallizing our three familiar dimensions out of a higher dimensional soup. The echoes of this great disentanglement might still be visible. The specific, uniform temperature of the cosmic microwave background across the sky could be a fossil of this event, a signature of a time when all points in our expanding space were once in intimate, immediate contact before the great dimensional divorce was finalized. This theory redefines the nature of the first crossing. There was no passenger on that wave, only the profound and irreversible act of separation, a single cut that created the inside and the outside for all that was to come. The laws of physics might be the universe's most successful ideas, infectious thoughts that jumped from a mind we cannot comprehend. Theory 29 proposes the first traveler was a cosmic meme, a pure, self-propagating pattern of information. A meme in our world is an idea that spreads like a virus, a catchy tune, or a cultural concept that hops from one brain to another. Now scale that to the birth of reality. This was not a tune or a joke. It was a fundamental piece of logic, a mathematical truth so elegant and robust that its structure was not bound to a single-dimensional framework. It existed as a potential pattern in a realm of pure information. When our universe flickered into being, this meme found a new host. It traveled by being instantiated, by imprinting its perfect logic onto the chaotic initial conditions of the Big Bang. Its journey was not a movement through space, but a leap of replication, like a single sentence being translated perfectly into 1,000 different languages at once. The very laws you take for granted, the speed of light, the strength of gravity, the rules of quantum mechanics, might not be arbitrary constants. They could be the unique signature of this first mimetic traveler, the specific way its perfect, abstract form expressed itself in the physical clay of our cosmos. This means the pioneer was not a thing that arrived. It was an instruction that was read, a foundational command that bootstrapped our entire reality into a specific, orderly existence. We can see smaller versions of this today. The golden ratio appears in snail shells and spiral galaxies, a mathematical pattern that seems to insist on expressing itself across vastly different scales. That could be a faint echo of the process, a smaller meme that successfully propagated throughout our universe's structure. The first and most powerful traveler set the entire rulebook, and every star, every planet, and every thought that followed is simply playing by the rules it brought with it. Perfection is a prison of endless silence. Before time began, the void was not an empty canvas waiting for a painter. It was a state of absolute uniformity, a flawless and eternal nothingness that left no room for anything else. This 30th theory suggests the first interdimensional traveler was not an explorer, but a crack in this perfect stillness. It was a flaw, a single, random quantum impurity that shattered the symmetry of the void. In a realm of pure nothing, even the tiniest irregularity is a cataclysm. This flaw was not a thing, but a relationship, a fundamental asymmetry that created the very concepts of here and there, of this and that. Its journey was not a voyage through dimensions, but the propagation of its own broken nature. As this crack in the cosmic egg spread, it did not just create our universe. It simultaneously forged a connection to every other potential void, every other state of non-existence that might have harbored its own flaw. The flaw itself became the first traveler, a bridge of imperfection linking islands of nothingness across an unimaginable expanse. Think of a perfectly still, flawless sheet of ice that stretches to infinity. Then a single microscopic fracture appears. That fracture does not just sit there. It propagates, branching and spreading, creating intricate patterns. The traveling tip of that crack is the pioneer, and the entire web of fractures is the map of its journey. Our universe, with all its galaxies and stars, is not the egg. It is the intricate pattern of the crack itself, a beautiful, complex scar left by the flaw's passage. This means that everything we are, everything we see, is fundamentally built from a mistake. The matter that makes up your body, the forces that hold atoms together, the very flow of time, all stem from that original impurity. We are not the children of a perfect creator, but the living descendants of a cosmic accident. And that accident is still traveling, its journey eternal as the flaw continues to spread through the multiverse, forever exploring the boundaries between what is and what might have been. From primordial consciousness to cosmic glitches, we have crossed a landscape of 30 incredible possibilities. Each theory, from a self-aware universe to a refugee particle from a white hole, offers a unique window into the moment everything began. These are not just stories, they are profound challenges to our most basic assumptions about reality, matter, and mind. They force us to question whether the cosmos is a mindless machine or a living, thinking entity, and whether we are merely inhabitants or an essential part of its ongoing self-discovery. The beautiful and humbling truth is that we may never know which, if any, of these visions is correct. Yet the pursuit itself is what matters most. This relentless drive to ask how and why, to push against the edges of the known, is what propels both science and philosophy forward. It expands our imagination and deepens our connection to the vast, mysterious cosmos we call home. So we leave you with this final question: which of these 30 paths speaks to you? Did the conscious universe, the mathematical meme, or the flawed void feel the most true? Share your thoughts in the comments below and let us continue this exploration together. Subscribe for more journeys to the edge of understanding and never stop looking into the great unknown.